And if you start looking at your phone's file system, you can probably figure out where they're jammed also. And more than likely, they're probably using the exact same algorithm as the desktop version of the application, I imagine. Let's use a little demo though. First thing we'll do is bring this back up, and I have Portable Pigeon on my desktop. And I'm going to go into a path which I don't know off the top of my head. However, luckily I have it written down here. Underneath data, and would help settings, and dot purple. If I go underneath here, I should be able to look in accounts. It's a little XML file. Look around and find my password. As you can see, it's bad password with a little bit of elite speak spelling. Now, that's doing it by hand. I was always talking about this messing pass from Near, which does a bunch of stuff for you already. It's really easy to use if you have everything in the default locations. I don't. It's this MS pass there. Since I don't have things in the default location, it didn't come up with anything. Luckily, it lets you point it to where things are located. And so I'm going to choose Pigeon, Browse, and I'm going to go actually find where it's installed. And I'm trying to remember where exactly I need to point it to. Let's see, desktop, Portable Pigeon, data, settings, purple, and say OK, and it extracts it for me. Now the only reason I had to go through those extra steps is because I'm not using the regular, normally installed Pigeon. I'm using it off of the mobile version, or the portable apps version. But as you can see, no problem recovering it. And that's another one of those ones where you don't necessarily need to be logged in as a user. You just need to create an account or grab a person's credentials some other way. Or they can say, you know, I'm having a problem getting on this particular chat. Why don't you send me your config files? I'll take a look at them and try to figure out why you're having a problem getting Pigeon to work. But it could be more than just Pigeon. It could be any old thing. Oh, stupid web app. This is going to be more of a rant than anything else because this app no longer behaves in this way. There used to be this streaming video application I was going to use, and I was going to go to ShmooCon. You know, when we got snowed in. Martha and myself, Elliot and John all had this like escape from LA kind of escape from New York style escape from DC through the snow. It was a bit of an interesting trip, especially since one of the guys from Paul.com, Mick, gave me some called sort of truce to drink. That was probably about the worst hangover of my life. But anyway, neither here nor there. While I was there, I was going to stream some video. And I have my own account on this particular streaming service. But as I was looking around, I found out when I was going to my profile, if I go to the password section, it only had a start off section in the form. And it was the same character count as my actual password. I'm like, huh. So I viewed the source. My password is actually in the form behind the source. Why would they ever do that? They've since fixed it, but I mean, there's dumb web applications out there that do that sort of thing. They pull the password out. Obviously, the password must be stored in plain text someplace in the database, or recoverable if nothing else, not as a hash. Why would they do that? I was going to show that in this presentation, but I've gone back to that particular service recently, and they don't do it that same way. Any old asterisks, or as I say, I'll show you mine if you show me yours. Now, how many people have seen an application? You're not sure where it stores its passwords, but you see that the password was there behind a whole bunch of asterisks. Well, there's tools out there. Now, the way this is normally done is somewhere in the Windows API, there's a style you can apply to a text box called an ES password. And so instead of actually showing you the text, what it does is it shows you dots or asterisks or some other possibly settable character instead. Well, you can easily reverse this in most Windows applications for Windows 7. Maybe this is what you're doing in Windows 7 tool also, but the tools I've played with so far haven't been able to do it. Some applications, though, let's say like Windows Users Management and Firefox, don't do it using that same way, so the tools out there won't work. I have something out there on called Asterisk Logger that's sent to you in a tool pack you can get from Nearsoft's site. what it would do is it would essentially take something like this, and you run it, and it would make the password reveal itself. Nice and clean. Unfortunately, I'm not going to demo that because I'd have to boot up XP to demo it, because when I try the exact same tool in Windows 7, it doesn't work. So they changed something about the way they do it. But a lot of times you can recover those things behind asterisks by using one of these tools. And Cain also has a tool that does much the same thing. Alright, network shares. Remember how I was talking about stored network credentials before? Not cache domain credentials, but remember when I was talking about RDP and how they changed the location of where passwords are stored now? Well, now they're stored in the exact same place as passwords with file shares. Like, have you ever accessed a file share out there on the network and you see this dialog box, like right here, where it says, remember my credentials? Well, you might wonder where those are stored. Well, apparently they're stored in these locations in these different operating systems. Either in the registry or possibly in the credentials folder underneath your profile, underneath app data, roaming, or local. You can actually go look at those and try deobfuscating them yourself. Luckily, those tools for doing that, which I showed earlier, this network password recovery, which if you go ahead and run that, and I kind of already demoed it, but for giggles, let's go ahead and show it again. NetPass. Not that I helped it any. As you can see, it revealed these. One of these actually happens to be to a server IG, and I used bad net password as my password. This other one happens to be to remote desktop. It just happens to store it in the same place now. It used to install it in the RDP. It used to do it in the RDP file.
So that's not the local user account. That's the network's.
Correct. But that's only if you choose to store your credentials when you try to log into a remote file share. And by the way, Cain has an ability to do much that same kind of thing as far as revealing it. But that's no reason to show you two different tools for doing it. Trust me, Cain can do it also. Let me see. And here's an example that Near actually has on his website. I legated this. I like using that term. I legated it. I legated this screenshot off of his website. But let's actually hear about the whole legat thing. That just amuses the living hell out of me. All right. Outlook PST files. Now, the reason I'm using Outlook PST files, it's almost like this is not even a real password. These are so weak. But I'm going to use this as an example of what's known as hash collision. A hash collision is where two different things hash to the exact same value. Obviously, this long string turned into this very short string. There's probably a whole series of long strings that turn into that very same short string. But finding them would be a difficulty. If it was really easy to cause hash collisions on various systems, you wouldn't have to type in the real password. You just have to be able to figure out something that would generate the exact same hash stored and use that instead. Well, that's exactly the problem with Outlook PST files. You can cause a hash collision. Apparently, Outlook PST files, they store their hashes as CRC32, which might be fine for checking integrity of the system. Normally, CRC32 is associated with, has this file been modified or changed? Has someone, did I get all this file across the network properly? It's meant for using those kind of purposes, not for password storage, because it's very easy to generate a collision. So that's essentially what the tools for cracking this do. I have a tool called here, PST Password, once again from Near. And we'll go ahead and fire it up. And I have a PST file on my desktop, which I may not know the password for. Actually, I think I do know the password for it. I think I said it once again to be bad pass.
Hey, Rick.
Yes.
When you say create a collision, you're just talking about coming up with a different password?
Different password that generates the exact same hash.
So Outlook wouldn't know the
So
difference.
when it does the check, it doesn't know the difference because it hashes what I input and it says, oh, it matches the hash I have stored, so you must have entered the right password.
Because Outlook doesn't know the password.
Right.
Okay.
It knows the hash of the password.
Okay.
But since there's multiple things to hash to the exact same hash,
Right.
there's multiple woods,
So if you're logging into a domain and you're going to an Exchange server, and you keep a local PST file, and it uses your domain password to log in.
Well, I'd hope you don't use your domain password as your PST's password. But
if you're on Active Directory...
Well, you don't have to. Not to mention, it wouldn't really help you because... All right, let me go ahead and actually run the tool to show you what I mean. I'm going to select the PST file in question. I put one on my desktop. I just called it test PST. It generated these possible passwords I could use. I could take that particular password and try entering it in the domain. It's not going to work because that's an entirely different thing. That password will not hash to the same thing that is stored on the domain controllers.
It's because the domain controller uses a different hashing algorithm. And so when you enter a password, it doesn't really compare passwords. It only compares hashes. So if the hashing algorithm is different, it's not going to work.
So if you've got Outlook set up to save a PST file locally, but you actually pull its information from there, is it going to...
Well,
can you use your domain password on that local PST copy?
No, because
No.
what this is doing is taking a long hash and rehashing it into a shorter hash.
Mm-hmm.
And so there's less possibilities of the shorter hash. So that way, if you have two words that hash the same and create the shorter hash, then you can use either one for the PST file. But that's not going to work unless you get the exact, for the PST file, you get the exact correct password, which probably won't happen because there's so many different possibilities. If there was a way to figure out that you had the correct password for the PST file, then you would be able to enter it in as the domain controller via the password. The problem is that's not how passwords work. They compare hashes rather than passwords. So the only way to be able to do that would be able to reverse the PST hash, which is more difficult.
So even though it's on there it is using the domain password on that local PST file, but this is not going to give it to you. It's just going to be a variation.
Correct. The only way that would be possible was I would have to generate an algorithm for every single possible hash for that password, and then I would have to try every single one, and even then it wouldn't work because the hashing algorithm is different. So then I would have to reverse every single hash, which is difficult. Even in, there's some simple hashes, but hashing as a general rule is not able to be reversed.
Yeah. And here we're not reversing it either. We're just generating a collision.
Yeah, I just didn't know if the local stored one did, in fact, use the same password. So it does. This just isn't going to give me the actual password.
Yeah, it's not going to... You'll be able to find a password that lets you into Outlook, but it's not that same password that this one I made. I'm not going to be able to get into the domain with it.
Yeah.
Okay. Like, you would technically possibly have the password, but it wouldn't do you any good unless you could somehow turn that hash into the domain controller hash. And even then, you wouldn't know if it was the right one.
Yeah, okay, I got it. Thanks.
All right, let me try entering one of these. Oh, good. Stuff popping up. All right, let me try to get into the test again. No, cancel. All right, file, open, Outlook data file, desktop. Let's try opening up this file. And this did work while I was testing it. I did actually test my live demos, strangely enough. That does happen sometimes. And there, it actually let me into this particular test message, this test PST. And if I go into it, I think I only have like one file, some secret message. And I didn't know the original password. I just was able to create a hash collision and able to get in. That's an example and in theory, you could actually do that if you have the hash from a domain controller or a system. In theory, you might be able to come up with a hash collision if some weakness is found in the hashing algorithm. CLC32, it's easy. Other hashing algorithms like MD5, while it's not as secure by saying as SHA, it's still, I suppose, possible, but not very bloody likely. Is that basically a good synopsis of that?
Well, the hash is so much longer. There's so many more possibilities. The weakness in this hash is that it's so short. And so the original hash is much longer. So when it's rehashed into the shorter hash, there's only so many